Hello again. Today we're going over a little bit more with those complex numbers. We're going to be multiplying and dividing complex numbers, but in trig form, which sounds like, oh man, that's going to be way more complicated than before. But actually, this is a whole lot easier, right? The math behind it is actually, pretty simple when you start to get into it. And that's why a lot of times we use trig form is because it's easier to multiply and divide when you're in trig form. It's easier to add and subtract in the kind of rectangular form. That's easier to do then. It's easier to multiply and divide in our new kind of trig form here. So that's what we're going to look at here is how do we multiply and divide stuff, right? So first question that I'm just going to show here, if you want to skip ahead and you don't want to really see why does it work this way, you can go ahead and do that. But I'm just going to show you here on Desmos kind of what does multiplying and dividing do. So I'm going to put this on here. And we're going to take a look at an example first before we go into the math. So here's an example, right? 3 cis 45 degrees, 5 cis 80 degrees, right? Again, this is cosine I sine. And what this is telling us is that 3 is the absolute value. That's how far we are from 0. Now we're at an angle of 45. Same with this one. So I'm going to set these two up. It's in a little different format here. Here I'm going to turn on, I suppose, degrees, so it makes a little more sense. It's just a different grid. This is our rectangular grid. This is our what's called a polar grid, so that you can graph angles a little better. So like if I wanted to graph that number 3 and 45, I'd move out 1, 2, 3 spaces. Each ring is 1 away, and then I'd move that to 45 degrees. So this blue spot is at 3 cis 45, right? That's where that spot is. And so if I wanted to do one that was at 5 cis 80, there's about 75 degrees. 80's got to be pretty close to that. And actually, I've messed this one up. I'm actually 1, 2, 3, 4. I forgot this middle one. So this one's actually at 4. So we got to back that up there. Now it's at 3, 45 degrees. So if I want to multiply these two, I've already set this up in here. It's available for you if you want to jump in and use this. I've kind of set this up so it's done the multiplying stuff right here. This just sets up an extra little line in there. But I've done that kind of all that distributing stuff in there. So I'm just going to turn that on. So blue times red going to make purple, right? I figured we'd put some art in there as well. So blue and red together make our purple. And so we can see purple, it's out at 15, and then its angle's a little more than 120. I don't know, maybe 125, 130, maybe some, I guess it's a little closer. So maybe 130 degrees. So in here, right, I would say this result is about 15 cis 130, right? Something like that. And so I can kind of take a look, well, what is actually happening? It kind of makes little sense. This is 5 and 3, and we're multiplying stuff, we got 15. So that part makes some sense, right? 3 times 5, I suppose, being 15. But what about the angle, right? How is that being affected? I mean, 5 times 3, that just makes sense. So let's grab these and kind of move this around, right? The piece here, what it's going to do, I suppose, if we move this around, notice if I keep this still at 5, at a distance of 5, it's still 5 times 3. This is at a distance of 15. But as I move this, it just kind of turns that other result, right? Same with this one. If I move this, it just turns the result. So really multiplying trig numbers, we can kind of see here, is just a rotation, right? It's just rotating these around. In fact, more specifically, what's going on is whatever the angle of the red one and the angle of the blue one are sort of just being added together to make the angle of the purple one, right? So very simply, right, we can see what's happening here, but very simply what's going on is we're taking this, right? And so I'm just going to grab this whole thing here. We're taking these two things, and what we do is we take the 3 and the 5 and we multiply them together. That makes 15, right? That's the 3 and the 5. And then the two angles don't get multiplied together. It's actually just a rotation. So these two just get added together. It's one turns by 45. The next one turns by 80 more. Well, we'd have a whole total of 125 degrees, which I said maybe it was 130 when I looked at that. Turns out it was actually exactly 125 degrees, right? So that's all you do. There's the result, right? That's it. That's all there is to it. You multiply the two things out here, and you add the angles in. That's it. And you can do this if you have multiple pieces here. You just do that like you do any multiplying. We just take here 2 times 4 times 8, which is 64. And then we just say this, well, in here we take 120 plus 88 plus 240, which I suppose that's 360 with 88 more. And that's 448 degrees. That's what that one is. So in there, that's not too bad. But here's one thing, right? If we've done 448 degrees, right? If we kind of think about that, that's a full circle and then 88 more, right? I mean, we've gone that little extra bit. So actually, we could simplify this a little bit by removing 360 from that and saying that that's actually just 88, right? We can reduce any extra rotation by 360 or, subtracting 360 or perhaps adding 360 if we need to. But that's multiplying them, right? We just multiply the front numbers or the absolute values and we add up the angles. That's all there is to it. And division, kind of the same thing, right? Although division is the opposite of multiplying. So opposite of adding is subtracting. And so what that is it's still a rotation, but it's just a rotation in the opposite direction. So I'm actually going to remove this here. So if we divide these things, it's taking the blue or the red angle minus the blue angle. I think that's how that's working. So in here, as I rotate it, it sort of rotates opposite there because whatever one's on the denominator, technically here blue's on the denominator. So it's going to act opposite there. So the top, whatever's on top, the red stuff's on the numerator, that's going to be a little bit different there. So it's the same thing. It's still a rotation when we do division. But here, all we do is we would just take these and divide them out. The numbers we do like normal. 27 divided by 3 is 9. And then the angle, what we do is just subtract these. Take 120 minus 75, right? So just to double check, because I don't have anybody here to double check me, 45 degrees. That's what that would be. There's the result. Okay. We divide the things and then we subtract the angles in there. That's the idea. If you do happen to go negative, which can happen when we're doing these division things, here we would go 8 divided by 10, which we just leave as a fraction. I mean, 8 divided by 10 is 4/5. If you wanted to write it as 0.8, you could. I'm just going to leave that as a number. And then we would do 100 minus 300, which is negative 200. But then we should adjust that, right? Negative 200 degrees is going backwards at, 200. So we'd want to say, oh, in actuality, if we kind of standardize that, we would add 360 to say it, and that's the same as landing at, 100, oops, not 120, 160, excuse me there. But that would be that rotation around the other way. So in the end, the correct answer in here, because we've adjusted that angle, is at 160. Okay? And that's all the steps. Okay? This last slide here, I just kind of put those general rules down for you. It looks really complicated, but all it is you multiply or divide, perhaps, the absolute values like normal. So here, A and B, take A times B, or A divided by B. That's exactly what we did. And then you just either add the angles if it's multiplying or subtract the angles if it's divided. And then, if you could adjust the angle by, adding different amounts of 360 or subtracting 360s until you got, a standard angle. But that's pretty much it. Again, if you guys have any other questions, go ahead, let me know. Otherwise, I'll see you later.